Thank you for this opportunity to share my master's work with you all today. I'll start out with my study objective. The objective of my study was to evaluate the effect of maturity on steer performance. And in terms of steer performance, I'm talking mostly about apparent dry matter intake and measures of in vivo digestibility. Little introduction to the study. Biomass has been recognized as a potential marketing opportunity for the American farmer. Growing characteristics of switchgrass make it favorable for a biomass crop, but developing a biomass market for switchgrass or a biofuels market using switchgrass is challenging because oftentimes the cost of the biomass or the cost of the switchgrass's biomass is relatively more expensive than coal or other fossil fuels. Also, there's a lack of government incentives such as tax benefits, and there's no mandate in terms of electrical or electricity production for biomass or biofuels to be initiated. Also, a challenge to switchgrass as a biomass market is the opportunity cost for farmers that arises from other crops, such as many of y'all have heard about the price of corn and soybeans, or other crops that might be better suited to the farmer's needs. So primarily in this study, I'm looking at biomass in terms that's already in place on the farm. So with those points in mind, we can't ignore the benefits or the potential to use switchgrass as a forage. We can't ignore that in developing the biomass industry. In the literature, changes in switchgrass forage quality with increasing maturity have been well documented. This is just a few studies that I've cited, but you can find many of those with a quick search. But few documented studies have considered changes in animal performance related to switchgrass stand maturity. As part of this study, I harvested both Alamo, a lowland type of switchgrass, and Cave Rock, an upland type of switchgrass. Those were harvested at two different locations, relatively close to each other, about 60 miles apart. I used standard haying equipment and procedures that the farmer would use in harvesting the forage as hay as round bales. The only exception is we tub ground the hay to 4 to 8 inch stem lengths to make feeding a little bit easier. The feeding trials were conducted at the Eastern Kentucky University Research Farm located near Richmond, Kentucky, and we constructed our own feeding facility for individual steer feeding. This is a little bit about the layout of the digestibility trial. We fed, for preliminary feeding, we fed Bermuda grass to transition from cool season grasses, or fescue that these animals would probably have had access to prior to the feeding study. We had a 7-day treatment dry matter intake adjustment period, and then we had a fecal collection period of 5 days. Now, if you'll notice that the time frame's relatively short, and that's one reason we didn't assess weight gain. We were just mostly looking at digestibility because in the literature, this process had been used before. This is a little bit about the lab procedure. There's a lot on there, and I'm going to ask you to refer to the proceedings. For most of the lab procedures, I am going to point out one thing. As part of this study, we used acid detergent insoluble ash as an internal marker. We determined acid detergent insoluble ash using the Van-Soest method, where we did an ADF on forage, fecal matter, and the refused feed or the orts. And that was a procedure as described in Cochrane and Gallion. This is just a layout of my treatments. I replicated this in 2 different trials. As you can see, the 2 cultivars, we allocated 12 steers to each cultivar and 4 steers for each maturity of switchgrass hay harvested. We harvested at the vegetative stage, the late boot stage, and the early flowering stage of maturity. For the statistical analysis, all of our forage quality parameters were analyzed using SAS as a 2x3 factorial design, differing with different levels for cultivar and maturity. All of our apparent dry matter intake, dry matter digestibility and crude protein digestibility results were analyzed as a 2 by 3 factorial design, differing by both cultivar and maturity. And then our responses were compared using the LSD function for the forage quality parameters and the PDIF option and SAS. So going right into the results, this is a forage quality, and if you look at that, for each cultivar you can see with crude protein content rapidly decreased as you delayed harvest past the late vegetative stage for both cultivars. Also, neutral detergent fiber, or the cell wall components, rapidly increased, and so did acid detergent fiber. And you can tell this is both an indication if you delay harvest past the late vegetative stage, then forage quality rapidly decreases, which is also in the literature. This is dry matter intake for Alamo switchgrass. The one thing that stuck out to me, as an extension agent, we're often using that 2.5% of body weight as intake, or 2% of body weight kind of as a threshold. And you can see we're well below that as harvest is delayed past the late vegetative stage. This is for cave-in rock. The effect wasn't quite as drastic. For the late vegetative stage, we didn't have quite as high of an intake on the cave-in rock, but also you can see is that the effect is a little bit less with the cave-in rock than it was with the Alamo and going to the boot stage. But early flowering stage, is you're looking at those similar levels to Alamo there. Dry matter digestibility, you can see that decreases as harvest is delayed past the late vegetative stage. When I look at this, I do look at those bar graphs, but probably as a producer, what would be more interesting to me is the portion that's not on the graph, because to me what this would indicate is waste. So that's the amount of dry matter in the forage that the animal is not utilizing, so the producer wouldn't be getting as much benefit out of the switchgrass as harvest is delayed. 10% doesn't look like much, but when you're talking about a 900-pound bale of switchgrass at 86% dry matter, that's quite a bit of difference in waste, 10%. And this is dry matter digestibility for cave-in rock switchgrass. The effect here, of course, they're not able to utilize as much dry matter. Less or more of it is lost at the late vegetative stage, but you can see with cave-in rock that effect is delayed going to the boot stage harvest. Crude protein digestibility. I wouldn't put too much faith into the percentage on the side of the actual numbers, because this was an in vivo feeding trial, and as many of y'all will know in the audience today, crude protein is a measure of nitrogen, and so when we're measuring in vivo digestibility, we're accounting for nitrogen in the feces and nitrogen in the forage, but there's lots of nitrogen that's shed in the feces, so I would expect these numbers to actually be higher than around the 75% mark. But the take-home point here still that drive home here is that crude protein digestibility does decrease with increasing maturity, and if you combine that with the forage quality, the actual content of crude protein is decreased, then that brings this effect, makes it more evident. So in conclusion, these results indicate when feeding growing animals, there's a decrease in consumption of Alamo and cave-in rock switchgrass when harvest is delayed past the late vegetative stage. Steers consuming Alamo and switchgrass harvested after the late vegetative stage of maturity will not be able to utilize the hay as adequately and will require crude protein supplementation. And then when harvesting switchgrass, it's very important to harvest at the late vegetative stage of maturity. And at the bottom here, the main point that comes from this is From these results, I would anticipate that we can feed hay harvested at the late vegetative stage to growing animals or to steers. And I just want to take just a moment and recognize the people that were involved in this. This was a collaborative study between Eastern Kentucky University, the CRAFTS program, or the Center for Renewable and Alternative Fuel Technologies, and the University of Kentucky. And I have to make special mention of the Governor's Office of Ag Policy because they provided the funding for this study through the Kentucky Agriculture Development Fund. And with that, I'll take any questions.
Question for David Davis.
So if I was looking right on the Alamo switchgrass on the, I guess it's vegetative stage, what was it that they were slightly over, was it 2% of their body weight that they were eating?
Yes.
Okay, and some of the work, that we have done grazing switchgrass, when we're keeping it in that vegetative state, early in the season, we're getting potentially like 2.5 pounds a day gain, which is better gain than I would expect looking at 2% intake.
Mm-hmm.
What would you think would be, why do you think we're seeing that difference? You're measuring 2% intake, but when we're grazing it, we're seeing 2.5 pounds a day gain.
Well, for one thing, if you think about, okay. I'm sorry. I need to repeat the question. So basically, Dr. Bates was talking about in some of their previous research, they had seen weight gains of 2.5% of body weight, was that right? Or 2.5 pounds per day, average daily gain. And I only saw dry matter intakes of 2%. And he was wondering why that is, or why did I not see higher intakes? Is that basically the question? So if you'll think back to my procedures, one of the things that I did is I tub ground this hay. In a grazing situation, these animals would have preference. So they would have preference of the leaf material, which is higher in crude protein than the stem material. Where I tub ground the hay and mixed it all together, they didn't have as much preference. And I think that would decrease intake and consume in this hay consumption, the way that we measured it. And also the methods of assessing, well, did you assess intake at all on pasture? Okay. But I think that's one of the biggest reasons.
Could there be a difference because of fresh forage and pasture and hay?
So he asked, could there be a difference in fresh forage and the hay? And the answer to that is absolutely. I mean, we're going through the whole process of harvest. There could be leaf loss. There could be so many things that could go on through this process that we can't really account for as reflected in intake here. And so when you're on pasture, you would have access to that whole plant. You probably have a little more nutrition, but I wouldn't really suspect those differences, to really account for that difference in intake. I think it's more of where we tub ground the hay and the selection. Anybody else?
Thank you very much.